I want to talk about performance tuning because it is one of the topics which is very vague, very vast, but still everybody expects us to know certain things about performance tuning. So there are certain important topics that I'm going to cover, because performance tuning goes in either direction. It goes in the DBA direction, it goes in the development direction, and finally it mixes. Even the operating system people are involved in performance tuning. So you have to have a lot of other areas knowledge to kind of do anything on the performance tuning side. So certain areas that or certain topics that we're gonna cover are indexing. So I will talk about basic types of indexes and all that stuff, how they are used to do the proper performance tuning. That is something we'll talk about. Then the second topic that I'm going to talk about is partitioning. Partitioning a table. A huge table is partitioned into subtables, and by kind of making a smaller table or smaller parts of a bigger table, we can go after only the specific data, smaller amount of data, and therefore the speed increases. So that is the partitioning mechanism. So we'll see how to partition a specific table to increase performance in only certain areas. Partitioning will not increase the performance in all areas, but only in certain areas. So that is the second thing that we'll talk about. Then there is something called as materialized views. We all know regular views. Materialized views, kind of a new thing that Oracle has introduced. It is actually a table. It is a table which is having a summary or aggregated data from some other tables. So instead of writing a query which is going to do aggregation or summary or group by or having all those, because those queries are very expensive, they take a lot of time if the amount of data is very huge. So instead of writing a query and waiting for the response, why not write a query and get the data, store it into some table, and that table is called as a materialized view. And then run the queries on the materialized view itself instead of running them on the base tables. So that is what a new kind of way, and this is heavily used in the data warehousing field. So we'll see materialized views also. And then while talking about the indexing, I'm going to talk about the optimizer. Optimizer is kind of a mechanism or a program that Oracle has built inside it. And how does the optimizer work? And once we understand the working of the optimizer, we'll talk about certain commands related to optimizer. We will see how indexing works very nicely. So during the optimizer functioning, we are going to also talk about what is called as a explain plan. So these are certain keywords related to performance tuning, and we will be knowing about all these things when we finish our discussion about performance tuning. Okay. So that's the first thing. So let us start with indexing now. Or I will start with the optimizer. Okay, I'll start with the optimizer first, because now what is an optimizer? Optimizer is a algorithm or a set of algorithm that Oracle has created over the period of so many years, I would say many decades now, and they have been fine-tuning that algorithm, fine-tuning those mechanisms, so that we can execute a specific query in a very faster way. Execute a query in a faster way. So I need to give you an example about that execution. Let us say we have a simple query written here: select star from the table orders where customer is equal to Shekhar. This is a simple query that we would like to execute. Now, how to execute this query is one of the major challenges Oracle has to decide on, because there are multiple ways to execute a query. Answer will be the same. Whether you follow this path or that path, the answer will still be the same. But Oracle has to decide how to execute that certain query. And the set of steps that Oracle is going to decide that these steps should be followed to find out the answer to this query, and those set of steps is called as an execution plan. So what is an execution plan? It is a certain set of steps that Oracle's optimizer program is going to decide. And there may be multiple set of steps. So for example, to give you an example, I would like somebody to go from this place to Alka Talkies. Obviously there are multiple ways to go to Alka Talkies, and a smart person will find out, okay, this is the shortest way, let me go from here to there, the quickest way to go over there. So that is what Oracle is going to decide, which is the quickest way, the shortest way to find out the answer to this question. There may be take a left, take a right, multiple steps, and go there. So execution plan are the set of steps that Oracle is going to decide to give the answer to this, and the fastest way. Now in older days, Oracle had that certain set of rules that if you go from here to here and left, and it is the shortest distance from there, for example, I'm just giving you an analogy, shortest distance, and take the shortest distance path. It does make sense. It is 1 kilometer from here and 5 kilometers from there. Take the 1 kilometer path, it will give you the quickest way. But over a period of time, Oracle realized that the shortest is not the quickest, or shortest may not be the quickest. Okay, so earlier time, Oracle had certain set of rules which kind of said shortest is the quickest, and those rules were called as, that optimizer was called as a rule-based optimizer. Rule-based optimizer were the set of algorithms, rules, which always thought the shortest is the quickest. Over a period of time they realized, no, it is not that, there are certain other aspects to it, and those aspects will kind of dictate what is the quickest way of doing it, and they started calling it as a cost-based optimizer. The cost is basically the cost of CPU, the cost of I/O, input-output, that is a disk I/O, and sorting. So cost number 1 is CPU, cost number 2 is I/O, and cost number 3 is sorting. These are the three main costs. That means the resources will be utilized. And based on that, Oracle is going to decide what will be the cost of executing this query. So there is some number there, that Oracle comes up with, that to execute this query, if you take step number A, step number B, step number C, and step number D, the cost will be 100, and that 100 is just units. It is not like 100 milliseconds or 100 something. Oracle has the internal algorithm, it will say. Then otherwise you take A, B, and C, the cost is 90. So obviously this is much better fashion. Or A, B, and D, whatever it is. And maybe there are A, B, C, D, E, F, and still the cost is only 10. Okay, so there may be multiple steps, the cost could be 10, and I will give you an example there. Okay, without the example we probably cannot understand this thing. But the point here is, earlier they were thinking less number of steps, take those and the job will be done. But then later on they realized, no, it is not that, the cost could be less even if the steps are higher. So same analogy, it may be 5 kilometers from this side, but there is no traffic this way. It's down the hills, and here there is a lot of congestion and all that stuff. So obviously based on those things, you are going to make a decision. So now to give you an example, how does the whole thing work? This is our query. Now how is the data stored inside the Oracle database? Data is stored on the disk. Okay. When your table is created, the very first thing that happens, actually when the database is created, what happens, there is one big gigantic data file. Actually there are multiple of them. There is a data file there, which is a huge data file that is created when the database is created by the DBA. This data file size may be 1 gigabyte, maybe 2 gigabyte, depending on how much of space is available. What is there in that data file? Nothing. Initially there is nothing, it is all blank. It just, small formatting is done here and there. But then when somebody creates a table, certain space out of that entire data file is now allocated to that disk, allocated to that table. Now the file is a file is a file. You go to the C drive, excuse me. You go to a C drive, you type that dir command or whatever, you see a file, size 1 gigabyte. What is in that file? Maybe one small extent. This is called an extent in Oracle's terminology. One small extent, and that extent actually is our employee table, first area. Now within that extent, Oracle has some terminology there. There are certain smaller areas within the extents, those are called as blocks. So you may want to remember that there is a smaller area as the block, the bigger area is the extent, and inside the blocks there are rows. So when we insert a row, that goes inside the first block. After the first block is filled, it goes into the second block, then the third block, fourth block, and likewise as you are inserting more and more data, maybe with the help of SQL loader or maybe with the insert statement, all these blocks will get filled, and then this area is totally filled. At that time, Oracle will allocate one more extent for that table, and again within those extents there would be blocks. Again data will be inserted in the first block, the second block of that extent. Likewise this is going on. So the smallest part of that table is a block. So now when I say select star from orders where customer is equal to Shekhar, how is Oracle going to give you this answer? Consider each of these blocks as a piece of paper when you are going through your book. Each page is a block. On each page there is a row. There are multiple rows there. Now I give you a book and say find out the row in this book which has customer is equal to Shekhar. How would you do it? You will go and read the first page. There is no row with the name Shekhar. Then you will go to the second page, no row with the Shekhar. Third, you find out, yes, there is a Shekhar. Will you stop there? No. Your job is to again go through the whole thing. Then the third page. Maybe on the fifth page, you again find a customer whose name is Shekhar. So what you are doing, you are going through the whole book, page by page. That is, you are going through the whole table, block by block, searching for each row, finding out whether Shekhar is there or not. So this activity of reading each and every block of a table is called as a full table scan. Full table scan is an activity of reading each and every block to find out your answer. So how did you find out your answer? Yes, you did a full table scan. The worst thing from the performance tuning point of view is to do a full table scan to find out the answer. But there was no way. Otherwise I could not have figured out where the Shekhar is. Okay, so in earlier days we used to do only full table scan. No problem. Then later on, what was introduced now? Is there any better way to do this thing? Yes, the better way is to create an index. Now what is an index? At the end of every book you have seen an index there. The important keywords. Word Oracle, word SQL, PLSQL, all those are there. Word PLSQL or word cursor is on page number 29, page number 38 and page number 16. That is the index at the end of each page. Now with the help of index, if I say find out all the rows that contain word Oracle, what would you do? If there is an index to the page, you will directly go to the index. Index is an alphabetically arranged thing. So you're going to go to A, B, C, directly you're going to go to O. Oracle is the word that you are looking for, and you're going to find word Oracle is on page number 25, 29, 26, 28. This index is already created. Obviously, time has been given, a lot of time was spent to create the index. But once the index is created, our searches are going to be faster. It's the exact same way here with Oracle. So Oracle is going to say, if you are going to write queries like this, where customer name is equal to Shekhar, those type of queries are going to be more oftenly written. Why not create an index on the customer column? Why not create an index on the customer column? So we execute a command called as create index. Name of the index is IDX1 maybe. On the name of the table is orders and name of the column is cust. This is the command that you will execute, and this command will actually create what? An index. What is an index now? An index is just like what we see at the end of the page. So it is like a two-page, I will erase this thing now. It is like consider it as a two-column table for our understanding. So customer Adam, he is on page number 12. Now this page number in Oracle, this is not a page number, this is actually a row ID. Row ID is the physical location of the row on the disk. So it's not a page number, it's a physical location. So in reality is a block and the row inside the block. What is it? So Adam is on that row ID number 12. Then B is Barbara is on page number 28. And likewise Shekhar somewhere. So this is all alphabetically sorted on page number 29. Something like that. So this is an index. It is separately created. It is kept somewhere else. Now table is here. Index is somewhere here. Index is on column customer ID. Now Oracle says select star from orders where customer is equal to Shekhar. Now Oracle says, okay, I have a index, with me. The index is created. So I'm, instead of going and doing the whole full table scan, which is only one step to find out the answer, I'm going to do this in two steps. What are those two steps? First, I will go and read the index. Reading an index is very easy because it is alphabetically arranged. I will go and find out Shekhar's row ID. So that is step number 1. Go to the index, find out the row ID. It will find out that row ID. Once the row ID is found, it is the direct location of that row on the disk. So it is like the page number. You can directly go to page number 29. You don't have to go to the first page, second page. You can directly go to page number 29. So likewise, second step is go back to the table, and in that table identify the row ID 29, and you get the Shekhar's data. So even though you have taken 2 steps, the time required is extremely low. That was the point that I was trying to do. Instead of having only 1 step, take multiple steps, 2 steps, and the time required is still less. And this is actually what the optimizer decides. Optimizer says, yes, we are going to use the index, and we are going to actually use the index. We're going to find the row ID, and using the row ID we're going to go to the table, and then we're going to get the actual data. So from the performance tuning point of view, it is very important to understand the purpose of an index. The whole this discussion was to just show you what is the purpose of an index. Index is a alphabetically sorted thing with the actual data and the row IDs. And since it is alphabetically sorted, and it is not just alphabetically sorted, it is arranged in what is called as a B-tree fashion, and we'll talk about B-tree a little later. So it is arranged in a B-tree fashion. It is much faster to search the index and to find out the row ID, and then go to the actual table with that row ID. And optimizer is the one who decides, instead of doing a full table scan, let us do a index scan first, find the row ID, and then step number 2, go to the table to find out that row ID and get the data. So I would say, I would suggest that you do this exercise. Create a huge table with at least 2 million rows. Okay, very quickly you can do the PLSQL program to create 2 million or 3 million rows. So obviously there would be a whole bunch of blocks for that table. Yeah, come on in. So there would be a whole bunch of blocks for that table, and all those blocks will be actually they will be read if we are doing a full table scan. If the index is not created, if the index is created, then Oracle will internally realize we don't have to do anything. All our job is just to create the index. Our job is just to create the index, and it will take care of the whole thing. Who decides that? The program which is called as an optimizer. So that's what the optimizer is. First step in our performance tuning. What is an optimizer? Now, just other things, terminologies that we need to kind of know from our maybe interviewing or from the examination point of view. What do we need to know? So what is an optimizer? It's a algorithm or a program which will decide the execution plan. So first step is, it will decide the execution plan. Okay, what are the different types of optimizers? Okay, the older one is the rule based. And what was the rule? If there are 2 steps, maybe take 2 steps, then 3 steps. Those were the fixed rules. Now the rule based, nobody uses that. It is there just for the backward compatibility. And so rule based optimizer. Currently what we have is the cost based optimizer. So we know these 2 different things. The best example to give is, and what is the cost related to that? So, cost of what? Cost is just in units. And cost is related to CPU, cost is related to IO, and cost is related to sorting, plus so many other things, but these are the 3 major things on which the cost of an execution plan is dependent. The execution plan is dependent on these things. The 6th thing to probably remember is what is a full table scan? Full table scan is reading each and every block of a table to get the answer to your query. It's a very time consuming and full table scan. Obviously you are reading all the blocks, so IO cost is very high. Your IO is disk IO. You are reading from the disk. And reading from the disk and writing to the disk, input, output, IO. So IO cost is very high when you are doing a full table scan. And disk is always slower. So what is a full table scan? You know that. So in order to increase the performance of our query, somehow we have to find out whether Oracle is automatically doing a full table scan. And if Oracle is doing a full table scan because it thinks that is the best thing, and we think the other way around, we have to instruct Oracle, and we'll see that later, how to instruct Oracle to do something else. So full table scans are very bad. How can we avoid full table scans? By creating an index. How can we avoid full table scans? By creating an index. That's all we do. And therefore we need to know about the word called as index scan. Index scan is reading the index and finding the row ID. That is the index scan. Obviously you need to know what row ID is here. Row ID is the physical location of that row on the disk. So this is our discussion about the optimizer. This is the discussion about optimizer, and now we will in the next kind of segment we will jump to the other things, about more details about the execution plan, and then we'll go from there. Okay, any questions?